In this video, we're going to take a look at why the law of sines works. Now, before we get started, we're going to understand the labeling convention that we're going to use throughout the video. So we're going to have angles alpha, beta, and gamma with side lengths of our triangle A, B, and C. Moreover, side A is going to be opposite angle alpha, side B is going to be opposite angle beta, and side C is going to be opposite angle gamma. That's for any shape or size triangle that we are dealing with. So as a quick reminder, if we have a triangle with that labeling convention, the law of sines says that the sine of alpha over A as a ratio is equal to the sine of beta over B as a ratio and is equal to sine of gamma over C. So those three ratios are all equal. Sine of the angle divided by the side length opposite that angle. So why does the law of sines work? Well, to show you why the law of sines works, what we're going to do is we're going to take that triangle and we're going to drop a line on that triangle, or better yet, a line segment. It's going to be perpendicular to side C, and it's going to go through the point at angle gamma. Now, this line is called an altitude of the triangle. We're going to label it as H because it is the height of a triangle with base C. So let's take a look at this altitude. Well, this altitude has split my triangle into two right triangles. One that has beta, the other that has alpha. Here we have those triangles highlighted. Now, let's take a look at the triangle with beta in it. Well, we know by definition that the sine of an angle in a right triangle is the ratio between the side opposite over the hypotenuse of that triangle. That's again by definition. So the sine of any angle in a right triangle is the opposite over the hypotenuse. For the triangle with beta, the side opposite is h and the hypotenuse is a. So sine of beta is h over a. And similarly, for the triangle with alpha, the side opposite is h. The hypotenuse of this triangle, the one we've labeled in blue, is b. So sine of alpha is h over b. Then we just apply some algebra to both equations. In our equation where we have sine of alpha is equal to h over b, multiply both sides by b, giving us b sine of alpha is equal to h. And in the equation where sine of beta is equal to h over a, multiply both sides by a, giving a times sine of beta is equal to h. Now, since both of these are equal to h, we can set them equal to each other. So we set b sine alpha equal to a times sine of beta. And then just algebraically divide both sides by b and divide both sides by a. If I do that, we get sine of alpha over a is equal to sine of beta over b. We get any other equation, ones with gamma and c, then we just use another altitude, use the altitude going through beta or at the point beta perpendicular to line segment B, side B there, or use the altitude going through the point at alpha and perpendicular to A. There is one little thing that we have to worry about, and that is if my triangle is obtuse and I want to draw my altitude, again through the point at gamma, but perpendicular to C, side C. If I try to do that, then the altitude is on the outside of the triangle. We're going to be using right triangles again, but slightly different right triangles. Now, just for a point of emphasis, my alpha and omega here that I've drawn are supplementary angles. They add up to 180. And one fact about supplementary angles with sine is that sine of alpha is equal to sine of omega when alpha and omega are supplementary. The two triangles I'm looking at are these two, the red one and the blue one. Again, we're going to use sine of beta is equal to the opposite h over the hypotenuse. In the case of beta, it's a, but this time we'll use sine of omega is equal to h over b. With a similar format, sine of omega is h over b. We multiply by b and get b sine of omega is h. Since sine of beta is equal to h over a, we get a times sine of beta is equal to h. Setting those equal, dividing by b and a on both sides gives us sine of omega over a is equal to sine of beta over b. But remember what we said about supplementary angles, sine of omega is equal to sine of alpha. So we get our law of sines, at least again, the first part of our law of sines. And for each pair, we can just draw the altitude of that gives us the height of the triangle with various bases, and it would give us the different equalities. We'd have sine of alpha over a equal to sine beta over b, like we saw. If you drew the height on base b, you'd end up with sine of alpha over a is equal to sine gamma over c. And if you drew the altitude where it intersects perpendicular to side A, then we'd get sine of beta over b is equal to sine gamma over c. So that establishes the law of sines. That's where the law of sines comes from. If you want to see another video about law of cosines, a link will be up on the screen for the law of cosines as well.